So this video is an overview of how to do a chi-squared goodness of fit test for a binomial distribution on your calculator. So on the left over here, I have some observed data that's been collected from flipping 3 coins. And we're told to conduct a chi-squared goodness of fit test at the 5% significance level to see if the data above flipping 3 coins follows a binomial distribution. Okay, so just like with all chi-squared goodness of fit tests, I'm going to need to calculate my expected probabilities to be able to calculate my expected frequencies. So I'm going to set up in a spreadsheet where I'm going to input my expected probabilities and my expected frequencies. Label them clearly, it's easy to get confused. Okay, my expected probability is for 0 heads is my first option. That's going to be if it did follow a binomial distribution, what would be the probability or my expected probability of getting no heads? So I'm going to go to Menu, Statistics, Distributions, and it's binomial PDF because I'm looking specifically at getting exactly 0 heads. So my number of trials, well, each time I'm tossing 3 coins, so my number of trials is 3. My probability of success is 0.5 if we're assuming it's a fair coin. And my X value that I'm checking for is 0, getting 0 heads. And I hit OK, and I hit Enter. And then I could drag this down for the next 4 rows and just edit the X value that I'm interested in. So I'm then interested in the probability of getting 1 head. That's just because that's my second row here. Then I'm interested in the probability of getting 2 heads. And then I'm interested in the probability of getting 3 heads. Okay, then I've got my expected probabilities. I need to get my expected frequencies. That's just going to be the expected probability multiplied by the total number of times you do this experiment. So I can get that just by summing all of my frequencies in the frequency table, which in this case is 200. So to make things quicker, I'm going to type in as if it's Excel using the cell reference. So this number is in cell A1. So A1 multiplied by, and we said that total frequency for this example is 200. I hit Enter. The benefit of doing that is when I drag it down, it keeps updating the cell references. Okay, great. Now I've got those. I can just input my observed frequencies. Oops, don't want that. And that's going to be exactly what I've got in the table. So 20, 60, 89, 31. And now I've got my observed and my expected frequencies. I can carry out the test. So Menu, Statistics, Statistical Tests, chi-squared goodness of fit. My observed list is my observed. My expected list, be careful, is my expected frequencies. My degrees of freedom is just the number of rows, in this case 4 minus 1, which is 3. Be careful if you do MAI-HL. You may need to change that degree of freedom calculation if there are any estimated parameters, but there aren't in this case. For SL, you don't need to worry about that. And then I hit OK. And it gives me my p-value and my chi-squared test statistic. I would then need to, in my workings, compare my p-value with my significance level or my chi-squared value with my chi-squared critical value. But that's all the calculator work.